Finally, I'd like to take a look at this little expression right here, and I want to figure out what, in fact, are the lengths of AB, BC, and AC. And the only thing we know is that B is the midpoint of the line segment AC. Well, if it's the midpoint, that means that this length is actually going to equal that length. And so, in fact, what I see here is that 5x minus 8, the quantity that represents that length of that segment, has to be the same as the quantity that represents this length, because this point is right in the middle. And so what do? Well, I'm going to solve this for x by subtracting 3 from both sides, 3x from both sides. And when I subtract 3x, what I see here on the right is just a 0. And here I see a 5x minus 3x is 2x minus 8. And now I want to take care of that 8, so I'm going to add 8 to both sides, not changing the value of the scales of the equation. And I see 2x, that becomes a 0, equals 8. And so I see that x equals 4. Now, you might get excited and say, oh, the answer is x equals 4. But no, the question was, what are these lengths? So now we have to figure out the lengths. So if we figure out the lengths, what is the length AB? Well, what I do is take x equals 4 and plug it in. So I see 5 times 4 minus 8. Well, that's 20 minus 8, which equals 12. So this length is 12. Now, we can check and see what the length of BC is, but we know it should be 12 unless we made a mistake because B is the midpoint. But is it? 3 times 4, it is 12. So it looks really good to me. And finally, what's the length of AC? Well, we know it's 12 plus 12 by our postulate, also known as 24. Neat. So finding lengths of line segments using geometrical ideas is absolutely a walk in the park. I'll see you soon.